One thing gamers can universally agree on is that today's AI wars have been painful to gamers, causing massive spikes in gaming hardware prices, contributing to large game studio layoffs, and leading to fears of games being overtaken by generic-looking AI slop. It's hard to remember now, but there was a time 30 years ago when a different type of AI war was instead beneficial for gamers, namely the first-person shooter AI bot wars. While today's bots help auto-respond to your emails and Slack messages and book your travel, the AI bots of that time were computer-controlled characters whose main purpose was to frag you in a game of multiplayer deathmatch. And AI then was very different from AI today because it wasn't based on large language models that required massive amounts of energy, hardware, and data to build and run. In contrast, they were relatively simple systems that didn't need more than a standard PC of that era, allowing hobbyists in the modding scene to be the driving innovators, two of whom were eventually hired to build bot AIs for the 1999 multiplayer FPS showdown between id Software's Quake 3 Arena and Epic Mega Games' Unreal Tournament. In this first video of a multi-part series, I'll focus on Quake and why it spawned, no pun intended, the AI bot scene, delving into the innovations and limitations of the first hit bot from that scene. In follow-up videos, I'll trace the evolution of these bots continuing from Quake to Quake 2 and Unreal, and then to 1999's showdown between Quake 3 and Unreal Tournament. The first-person shooter bot modding scene was started by 1996's Quake, and it's worth knowing why, since this informs understanding how bot AI would later evolve. The first question is why Quake, rather than id's huge 1993 hit shooter Doom, would spark the proliferation of AI bots. There are a couple reasons for this. The first set of reasons revolve around the general gaming context, which drove the desire for multiplayer bots. First, while id designed Doom and Doom 2 primarily as single-player games with multiplayer features added on, Quake was designed with multiplayer as a primary game mode. For example, while Quake wasn't the first FPS game released with dedicated multiplayer-only maps, Quake was the first id game that released with multiplayer-only maps. Also, the Quake engine was architected specifically with a client-server model to allow multiplayer servers and other networking enhancements. Michael Abrash, who worked on the Quake engine with John Carmack, explained why this was different from Doom in his article about the Quake engine. Specifically, Doom had a peer-to-peer networking architecture, meaning each player's machine runs the whole game engine. This means that all players in a multiplayer game have to run their machines in sync, which works fine for two-player games over a modem, but runs into problems with games on the internet with many concurrent players. In contrast, Quake's client-server architecture meant that all gameplay and simulation are performed on the server, and each client, meaning a player computer that isn't designated as the main server, runs other processes just for that client, like graphics rendering and control input. The third factor was the growth of the internet since Doom's release in 1993. Interestingly, John Carmack originally thought that most players would play multiplayer Quake over LAN or local networks, just like Doom. But the growth of internet matches quickly caused them to release the Quake World Update, which was a separate Quake source port focused on internet multiplayer enhancements, such as handling internet latency better and providing matchmaking capabilities. These conditions together further spawned a dedicated competitive multiplayer scene around Quake, beginning with the first QuakeCon held on August 1996 near id's offices in Texas. Given all these factors, many people wanted a way to play or practice multiplayer Quake without carrying their machines to LAN parties or having to rely on slow, unreliable internet connections. Now that we've covered some reasons why players were wanting multiplayer bots, let's explain what was special about Quake that enabled the creation of bots. The core change that id made to modding in Quake was providing a separate compiled language called QuakeC that separated out various bits of game logic that modders could change and package into mods, including weapons and monsters. This allowed modders to define new monster AI in a C programming language-like syntax without needing access to the core proprietary game engine. Of course, the language itself was quite limited. Doom, in contrast, supported only modifying content such as levels and textures, and all AI was strictly located within the game engine and therefore inaccessible to modders. This meant we didn't see bots for Doom until id publicly released the full Doom source code in December 1997, which granted modders the full keys to the engine, so to speak. With this context about why and how Quake bots came about, we can start understanding the ingenuity and limitations of the bots. We'll start with the Reaperbot. The Reaperbot was developed by Stephen Polge, who at that time was working as a programmer at IBM. The Guinness Book of World Records lists the Reaperbot as the first computer-controlled deathmatch opponent, though whether this is entirely correct is probably up for debate. Released in October of 1996, just 4 months after Quake's launch, the Reaperbot was innovative for behaving more realistically than previous bots and for being able to navigate new levels without pre-existing knowledge, what Polge called dynamic level learning. This was contrasted against earlier Quake bots such as the Eliminator bot, which is one of the first Quake bots. The Eliminator bot required waypoints placed in maps for navigation. To add these, users had to create their own map files with waypoint coordinates hand-placed in, and then use id's map compilation tools to compile these into optimized BSP files that the game could load, which, not surprisingly, wasn't very appealing. Even though Polge never released the source code to the Reaperbot and also never officially finished the bot, we can piece together how it works from his release notes and from other modders who studied the bot's behavior and or tried decompiling the mod. At a high level, the Reaperbot had 3 things that enabled its AI. The first was a breadcrumb or node graph that mapped out where the bot could go and how to get there. The second was memory about useful Quake entities in the level, such as weapons, power-ups, doors, etc. The third was what Polge called a fuzzy logic implementation for decision making, which meant using probabilistic scoring to decide what the bot should prioritize doing at any time. The first 2 of these relate to dynamic level learning. In other words, as the bot explored the map, it stored a representation of how it could travel around the map as a graph in its memory, and it also stored the 3D locations of interesting things it encountered. Think of it similar to a Roomba vacuum, blindly bumping around the room to map out its walls and layout. So as the bot discovers new parts of the map, it updates its node graph to optimize the number of nodes, since storing too many nodes eats up computer memory and slows down game performance. It then uses standard algorithms to create what's called spanning trees, which are minimal routes connecting all the nodes that can be used for navigation. Polge's release notes mention each bot having multiple spanning trees, which likely exists to support alternate routes through a map. The fuzzy logic piece then decides what the bot should do at any moment, and utilizes the node graph and its memory of Quake entity locations to determine how to get there. At a simple level, the bot used equations to calculate some normalized probability score from 0 to 1 for whether it should heal, get a better weapon, attack the player, or do some other action. And then it picks the highest scoring action until that was achieved, or it reevaluated its decision again due to some other triggering event. Within each action, it might then have sub-actions to decide upon. For example, when entering combat mode, it might similarly score whether it should circle strafe or utilize a rocket launcher over the shotgun. Again, the specific details and implementation were never revealed in depth by Polge. In practice, the bots worked well enough for the time, but had several major weaknesses and was also controversial for other reasons. Many of the issues were pointed out by the creator of the Omicron bot, which we'll discuss next. One limitation related to breadcrumb caching. Since its cache, or memory for storing these breadcrumbs, is limited, in complex levels it starts having problems navigating because it fundamentally can't store enough nodes to create a good routing graph for it to navigate the level effectively. Its fuzzy logic also seemed to overemphasize camping, and once it found some set of powerful weapons and armor, it tended not to explore as much of the map. Third, the bot was also quite limited in its movement and prioritized staying on the ground, meaning it couldn't perform jump maneuvers like a human player would. A more controversial issue was cheating. Reaperbots can do things human players can't. For example, they can grab weapons that aren't within distances that apply to players, they tend to gang up on the player instead of each other, and they don't get bounced around by splash damage from rockets and grenades. Modders like Mr. Elusive also believed they could fire at faster rates than humans, although Polge categorically denied this in his README file. Polge made several updates to the Reaperbot. Most were bug fixes and minor changes, but these also included some interesting additions, such as allowing others to create and add new skins to bots, and allowing bots to dynamically adjust their skill levels based on how they're performing relative to the player. Unfortunately, the Reaperbot was never officially finished, and its source code was never released for others to build upon. Polge's last update to the bot came in November 1996, only about a month after the first public release of the bot, and by December of that year, news had spread in online bulletins why. Epic Mega Games had hired Polge to work on the AI for their upcoming shooter Unreal. The first major AI hire in the bot AI wars had occurred. I hope you've enjoyed this initial dive into Quake bots. Please like and subscribe to get notified about follow-on videos, and thanks for watching.